as a first exercise, can we write down all the identities that we know now, the trigonometric identities?
On the Jamboard?
Yep. Nice, that's good. That's one of them. On the other slide, I'm just going to write, just going to put the questions that we're going to be doing. Okay. Right, let's see what we have. So sine squared x plus cos squared x is 1, yep. Sine x over cos x is tan. Tan squared x plus 1 is sec squared x. Sine x equals 1 plus cos x. That one's not an identity.
Oh, sorry. Is it sine x squared plus 1 cos x?
No, but look at the top identity and then see if you can rearrange that one. And I think you'll get what I think you might be.
Oh, well, minus, sorry.
So.
Wait, no, sorry.
No problem.
Is it sine x squared equals 1? I'm not sure if it's minus or plus cos squared.
Elia, what do you think? Aisha, sorry. What do you think?
Is it 1 take away cos squared x equals sine squared x?
That's the one. Oh, yep. So we've got 1 over tan x equals cot x. So the sine x equals 1 plus cos x still should be gotten rid of. And the same with the cos x equals 1 plus sine x. But then there is another one, another identity.
I can't remember what it was.
Well, you can get it from the sine squared x plus cos squared x equals 1. It can be derived from there.
Oh, would you do... Oh no, I can't remember it.
Okay, so I recommend as a good exercise at some stage to use the sine squared x plus cos squared x is 1 to derive the other identities. I'll remind you for now, it's 1 plus cot squared x is equal to cosec squared x. So those ones are the ones. And these are actually going to be the identities that we'll need for questions to come. We've got sec squared of theta equals 3 tan theta. So we want to solve this equation. Problem is we're working with sec and tan, but we either want to just work with sec squared or sec theta, or we just want to work with tan theta. So first question, you can refer back to the previous slide if you need to. What's an identity that relates both sec and tan?
Tan squared x plus 1 equals sec squared x.
Yes. So we've got the tan squared x plus 1, or tan squared 1 plus tan squared theta is identical to sec squared theta. And why is that useful here? Well, with this equation, we can now change this sec squared theta to 1 plus tan squared theta. And that is equal to 3 tan theta, as per the question. Does that make sense so far?
Yeah.
Cool. Kieran, does that make sense?
Yeah, it does. Thank you.
Cool. Then, now what kind of equation have we got?
A quadratic.
It's a quadratic one. So we rearrange this to make 0 the subject. So putting everything on the left-hand side and reordering it a little bit, we have tan squared of theta minus 3 tan theta plus 1 is equal to 0. And then now we just need to solve this. So do we know how to solve a quadratic equation like this?
Minus b plus minus square root of 2bc over 2a.
So I think you're trying to go for the quadratic formula. What is the quadratic formula?
Plus minus b squared. No, b squared plus minus square root of 2bc over 2a.
No.
Oh no, it's plus minus b. Oh no, I forgot it.
So it's minus b
Oh.
plus or minus the square root of b squared minus 4ac all over 2a. So there's that. And then in our equation, we know that a is equal to 1, b is equal to minus 3, and c is equal to 1. So from that, we get that tan theta is equal to minus b, so minus 3, which is just 3, plus or minus the square root of b squared, so that's minus 3 squared minus 4 times a times c, and that's all divided by 2 lots of 1. In particular, that's 3 plus or minus the square root of 3 squared is 9, 9 minus 4 is 5, all over 2. So we get that tan theta equals 3 plus the square root of 5 over 2, or tan theta equals 3 minus the square root of 5 over 2. Does that make sense so far?
Yeah.
Yeah.
Cool. Okay, now we'll see how much you remember. Can we work out what the values of theta will be? So I'll give you both maybe a couple of, just 2 minutes, so until 25 past, to see if you can work out how many different values of theta you can work out. Cool, okay, so 25 past. What did we get anything?
I got for 3 minus root 5 over 2, x equals 20.905 and 200.905.
So theta equals 20.905, did you say?
Yeah,
Okay, and you also got what?
200.905.
Okay, 200.905. Okay, before I say whether I agree or not with those answers, for the other one?
69.09 and 249. 0.09.
So theta equals 69.09 and what, sorry?
209.09.
209.09, did you say?
Yeah. Oh no, 249.
Okay, again, before I say whether I agree, not agree, Kieran, what answers did you get?
I'm not really sure, to be honest.
Okay. So, Asha, how did you get these answers?
On the calculator, I did the graph thing, and then like on the graph thing, I put in tan x, and then I put in the equation.
Ah, okay, you put in tan of x equals, and then you did 3 plus root 5 over 2, and it solved it for you.
No, on the graph thing, I put in tan x on the first one, and then on the second one, I put in the equation, and then you press intersect, and then it tells you the points, right?
Ah, fair enough. Okay. So, okay, you got the calculator. That's good. Using leverage, getting the calculator to do things for you. It's a good tool. Which calculator is it you have?
I have the graphical one, the one with color.
Yep. I know which one you're talking about. Cool. Okay. So that's cool. Yep. So typically, you would get these answers first of all if you didn't have that, but it's good if you do. Theta equals the inverse tan of 3 plus root 5 over 2, which then gives you the 69.09. And for this one, you would say theta equals inverse tan of 3 minus root 5 over 2, which would give you the 20.905. But then the question is, how do you get this other value, 249.09 and 200.905? Well, by drawing a tan graph, and quite nicely, tan is the easier one of all the graphs out of sine and cos, and tan, I personally think. You get that this is 90, 180, 270. Basically, any 2 points like this, where the tan graph repeats itself, are always going to be 180 degrees apart. So if you got a particular value for tan, just add or subtract 180 as many times as you need to get other solutions that are in the range. Does that make sense?
Yeah.
So the 69.09, you would just add 180 on, and that gives you 249.09. The 20.905, again, add 180, and you'll get your other solution of 200.905. Does that make sense, everyone?
Yeah.
Yeah, thank you.
Cool. But yeah, that's the solutions to this equation. Okay. Let's look at the second one. And what I'm going to do, just to make things less complicated, is I'm not going to do things in terms of radians, because this is in radians, not degrees. It's in between pi and minus pi. Pi is actually 180 degrees, and minus pi is minus 180 degrees. So I'm just going to cross this out and say that instead, theta is in between those 2 degree angles. So similarly, what identity can we start with? That's the first thing. And how can we change it all so that it's all in terms of maybe sec, just to help you out. So again, I'll give you just a couple of minutes to have a go with the starting point. You may use the previous slide to help you get started. Okay, just to check, what first steps have we made?
I substituted tan squared theta plus 1 for sec squared theta.
Yep, so in this equation, we've got tan squared theta plus 1 here and here. And we've got that equation, I guess, tan squared theta plus 1 is identical to sec squared theta. So how can we rewrite this equation?
Sec squared theta take away 2 sec theta equals 0.
Lovely, because the tan squared theta plus 1 underlined in blue is sec squared theta, so that all gets replaced with sec squared theta, and it's minus the 2 sec theta, which then equals 0. Okay, where can we go from here?
You can factorize it then, so it's sec theta bracket sec theta minus 2.
Indeed, yes. We get sec theta like that, open bracket, sec theta minus 2 equals 0. That helps.
And then sec theta would be equal to 2 and 0.
Yep, so sec theta equals 0, or sec theta equals 2. How do we deal with this now?
So sec theta equals 1 over cos equals 2.
Okay, yeah. So we have 1 over cos of theta instead of sec theta, which equals 2, because that is what it is.
And then would you do the inverse, which would just be cos?
Well, to help you out with this stage, in fact, Kieran, do you have any ideas?
I'm not sure. I was kind of confused until now.
Wait, are you still confused?
No, I understand now because I was doing I was trying to find tans instead of secs.
Okay, so, well, yeah, now that we've got the identity, you've realized that we can change
Yeah.
that. But okay, so from here, what can we do to work out the value of cos theta?
Would you? Well, I'm not really sure to be honest.
Okay, so we're trying to get cos theta by itself.
Oh, would you times the 2 by cos?
Sure, and what would that give us?
Give you 1 equals 2 cos.
Okay, 1 equals 2 cos theta.
Yeah.
And then?
Would you divide by 2?
Yep, giving us...
A half equals cos theta.
Yep, a half equals cos theta, or I'm just going to write it the other way around. Cos theta is equal to a half. And then from here, we can work out various values of theta. So I'm going to let you both try this one. Okay, so any suggestions for what theta could be?
I got theta equals negative 60 and 60.
Negative 60 and 60.
Yeah, I got that too.
Okay, so how did we do it?
Cos negative 1 brackets a half equals 60.
Okay, so from here we have theta equals cos minus 1 of a half, and the calculator would give us 60. Kieran, how did you get the minus 60?
I just went like backwards because it says minus 180.
But how do you know it's going to be minus 1? How do you know it's going to be minus 60? Like, what other values could you have?
I'm not really sure. I was trying to figure that out. Do you take it away from 180 or do you add 60 to 180?
Okay, so there's something related to the 180 business. That's for sure. So just drawing a cos graph. This bit's going to be 90. This bit's going to be 180. This is 270. And this is 360. Minus 90 over here. This part here is going to be minus 180, minus 270, and so on. So we've got the line for a half. So we need to draw that in, which is like here, roughly. And in particular, we know that this part is 60 because it's what our calculator gives us. So to generate other values, well, we can always just use the symmetry of the graph. So this is 60, and cos is symmetrical about this line. So therefore, this bit, where it hits the graph again, is going to be minus 60. Here's a question, though. Using the symmetry of the graph, what value would this be? And what value would this be?
Would it be 120? No, not 120.
Ken, what do you think it might be?
Which bit? The green bit?
Yeah.
Would it be 330?
How? Why?
Would you actually no, would it be 300?
Why?
Because the difference between the 60 and the 90 is 30, and then if you add that on to the 270.
Indeed. Yeah. So you've got this bit here. This gap is 30. So in the same way, this gap reflects, and it's also 30. So 30 more than 270 would be 300. Now, of course, this is going outside the range, so don't worry too much about that. But it's just showing you how you would use the graph to generate other values. So yeah, nice, good stuff. Another question then, what solutions can we generate from here? From this one?
Would it be 90 and 270?
Well, that's if it were cos theta equals 0. It would be.
Would it be from negative 180 to 180?
Again, well, how did you get that actually?
Because it equals 0.
Sec theta equals 0.
Oh. Oh, wait. Oh. No, cos negative 1 to power. No, cos negative 1, 0 equals 0.
That's not true.
Oh no, cos negative 1, 1 equals 0.
Cos minus 1 of 1 is indeed 0, yes. But with this one, actually, bit of a trick. There's actually no solution because sec theta can never, ever be 0. So, in actual fact, sec theta is either greater than or equal to 1, or sec theta is always less than or equal to -1. And given that cos is 1 over sec and cos is always between 1 and -1, taking the reciprocal, sec is always going to be anything greater than or equal to 1 or less than or equal to -1. So yeah, with sec theta equals 0, there's no solutions. And also we can look at it mathematically here, where sec theta is 1 over cos. 1 over cos theta equals 0, but then if you multiply both sides by cos theta, you get 1 equals 0, which is just the problem there. So yeah. But so yeah, these are our solutions, 60 and -60. Cool. Any questions?
No.
No, all good.
Cool. Okay. Third one. So again, just 1 minute to think about what identity we're going to need, and then how we can form a nicer quadratic equation. Okay, so what identity are we going to use here?
Would it be cosec squared theta plus 1 equals negative cot squared theta?
Well, what's the original identity that we know?
Cot squared theta plus 1 equals cosec squared theta.
Okay, so cot squared theta plus 1 is identical to cosec squared theta. So then, if that's true, then what substitution would we have to make here?
What do you mean?
So you were saying cosec squared plus 1 is negative cot squared theta.
Yeah,
Do you get that?
because oh wait, so if I'm not sure.
Okay.
Oh no, oh never mind.
Any other suggestions then? It's okay though, it's good to suggest.
Oh, would you change the cosec theta to 1 plus cot theta?
The cosec squared theta.
Cot
Plus
squared theta.
So cosec squared indeed is going to be 1 plus, or cot squared theta plus 1, but 1 plus cot squared theta. So there's that part, and then there's the plus 1 equals 3 cot theta.
And then you bring the 3 cot theta to the other side and add the ones together.
Indeed. So we get cot squared theta, taking away 3 cot theta, add the ones, we get plus 2 equals 0. And then from here, we've got a nice quadratic equation that we can solve. This one looks like it can be factorized too, so I'm going to let you both have a go.
With x equal 2 or 1.
Looks that way to me, yep. So this factorizes like this. So therefore, yep, cot theta equals 2, or cot theta equals 1. So from that, how can we work out the value of tan theta?
1 over tan theta equals 2, and 1 over tan theta equals 1.
Yep, 1 over tan theta equals 2. 1 over tan theta equals 1.
And then you bring the tan theta over to the other side.
Yep. And then, was I right?
1 equals 2 tan theta, and 1 equals tan theta.
Yep. Then what next?
And then you bring the 2 over to the other side,
Mm-hmm.
and then you get half, and
Yep.
you do tan to the power of -1. I mean tan -1 and then half.
Yes. So here you do inverse tan. It's not actually to the power of -1. It's weird because the symbol looks like it's the same, but they don't mean the same thing.
Yeah.
But yes, you've got theta equals tan to the -1 of a half.
And you do the same with the 1.
Yep. So theta equals tan to the -1 of 1. And our calculator should give us some values.
Tan, the inverse of tan to 1 is 45.
Yep. So for
And
this one, theta is 45.
the half one is 26.57.
Okay, let's go 26.57. And what was the way in which we can generate our other values of theta for tan? Tan was the easy one, so I mentioned it on slide 2.
Would you
Mhm.
plus and minus 180?
Yep, as many times as you need to be able to get your other values. So 26.57. Are we going to plus or are we going to minus? Or are we gonna-
Oh no, you plus.
Why?
Oh no, you minus.
Okay, why not plus?
Because it will be bigger than 180 then.
Yeah, so that would give you like 206.57. So, but that's outside the range. So yeah, we want to subtract. And that gives us
And negative 153.43.
say that again, sorry. Minus.
Negative 153.43.
Yeah. Lovely. So that's our other value down here then. So theta equals minus 153.43. And then for this one here, for 45.
And you take away 180 to get negative 135.
Nice. So it gives us minus 35. That theta there. And yeah, those are our solutions. So again, it works a little bit like, it works very much like first year, except we're just using more identities, different identities. How is that for us so far?
Good.
Good, thank you.
Cool. Okay. One more for today then. Rather than going 0 and 2 pi, by the way, given how I converted the other one on slide 3 from radians to degrees, what angles do you think this would be in between?
Would 2 pi be 360?
Yeah, if pi is 180, 2 pi is just going to be double that, which is 360. So I'm just going to cross this out, just go for degrees. So 0 is less than or equal to theta, which is less than or equal to 360 degrees. Cool. So again, I'm going to let you both have a go at this one, and I'll check in about 3 minutes or so. Is that all right?
Yeah.
Cool. Kieran, is that okay for you?
Yeah, all okay.
Cool. Do we both know what we're doing at this stage?
Yeah.
I'm a bit confused.
With which bit?
I'm a bit confused on how to get the cot.
Well, what's the identity that you're going to use?
I'm not sure.
It's the same as the one that we used in the last one.
Oh yeah, sorry. All right, thank you.
Okay, no problem. Okay. So how do we start?
You change 1 take away cosec squared theta with cot squared theta.
Okay, so we'll just write the original identity just to be clear with that. So 1 plus cot squared theta is identical to cosec squared theta. So rearranging this identity, taking away cosec squared theta from both sides and taking away cot squared theta from both sides, we actually get 1 minus cosec squared theta is identical to minus cot squared theta. All good?
Oh.
So therefore, we get cot theta is equal to minus cot squared theta. So I'd always recommend writing out the original identity and then working from there, because otherwise it is so easy to make like little errors. But it's fine. I'll let you both carry on. So at this stage, you can both suggest what we would do next.
Would you put the cots on one side?
So yeah, what would I end up with then?
Cot theta plus cot squared theta.
Yeah, so if we take the cot squared theta from the right hand side to the left hand side, we get cot squared theta minus cot theta is equal to 0.
And then you factorize it.
Yep. So what does that look like?
Cot theta brackets cot theta plus 1.
Say that
Oh no,
again.
minus 1. Cot theta minus 1.
Cool.
And then you get cot theta equals 0 and cot theta equals 1.
Yep, cot theta equals 0 or cot theta equals 1.
And then you change cot theta for 1 over tan theta.
Okay. So we'll talk about that.
Would that one not be would that one not give any solutions?
Wow, so if you say that, why?
Because if you times it by 0, it'd just be 0.
If you times it by 0, it would just be
0.
Yes. Well, yes, if you times it by 0, it would just be 0. So yeah, you're not gonna actually it's not gonna work out. That's one way of thinking about it, yeah. And you also can't have 1 divided by something to give you 0.
Oh, would you change it for cos x over sin x?
Well, that's one thing I was thinking, oh, what if you suggest that? But that wouldn't work either. Because it's weird, but it won't work because if you put cos theta over sine theta, which is 1 over tan, that would give you cos theta equals 0. But the problem is, you can't, given that cos theta equals 0, and this is 1 over tan theta, well, this would give us that theta is equal to 90 degrees. But if you have 1 over tan theta, you can't have 1 over tan of 90 because tan 90 doesn't exist. Tan 90 has, is either positive infinity or negative infinity, and you get problems there. So in actual fact, your initial thing of saying timesing both sides by tan would give 0 is the correct one in that it won't work.
Oh, okay.
Yeah. So this one, there are no solutions. So you can cross that one out. What about for the other one?
Tan inverse tan 1 equals 45.
Sure. So first of all, let's maybe rewrite it. So 1 over tan theta equals 1. So therefore, tan theta must equal 1. And then theta equals tan to the minus 1 of 1, which equals 45 in the calculator. And then?
You add 180 to get 225.
Yes. So therefore, theta equals 45 and theta also equals 225. If we added 180 again, then that answer would be outside the range. So there we go. Any questions there?
No.
No, it's all good.
Lovely stuff. All right, well done to you both. And yeah, that's it.